Alrighty, here we go. We're going to prove how you can prove things are rhombi and or squares. Today you will prove a set of points is a rhombus, a square, or is it a rectangle? Or could it be all three? Kind of works that way anyways. By the way, if something's a square, it's going to be a rhombus and a rectangle, because guess what? A square is a rhombus and a rectangle put together. So what are we going to... Whoopsie, that's not what I meant to do. What are we going to do? How are we going to set this up? Okay, let's remember some things here. On a rectangle has four 90-degree angles at the corners, and the diagonals are congruent. A rhombus has four congruent sides, but the diagonals are 90 degrees. And a square is all of the above. So what I would do is I would focus on the diagonals first, because that's less work. Okay, so let's look at this. Let's get an example. Okay, so we're going to look at the diagonals. Here are 4 points. Now, kind of keep this in mind, I'm going to find the distance slope, and I'm just drawing this out so I kind of know. The diagonals here are JL and KM. So notice how it goes to the, skips a point, okay? Or MK, doesn't matter. I'm going to use the distance formula, and you're seeing how I set this up. Notice how I'm setting this up first, and the slope formula. I got to do both. So on this one, I've got to do both. I can't just do one or the other, so I've got to do both. So I'm putting here the points for J, -7 and -2. Notice X, Y. Then L, 9, 2. And then I would do M, or K. I guess I think I did K first. 0, 4. And then M, 2, -4. Okay. Then notice how what's in parentheses there ends up here in the slopes. Okay. I put those into the calculator and I get, for the square roots, 272 and 68. And for the slopes, 1/4 and -4. Okay, so here the diagonals have a different distance. They're not congruent, but they are perpendicular because they are opposite reciprocals. So if you go back to over here, if the diagonals are 90 degrees, that means they're perpendicular, which means they are opposite reciprocals. But their diagonals weren't congruent. So here, based off this, I'm saying that since they're reciprocals, but they're not congruent, it looks like it's a rhombus. Now how can I confirm that? Let's look at the sides. If I do the sides, then I can say if these two sides that are next to each other, and let me come back here for a second. If these two sides, JK and KL, are congruent, then I know that's a rhombus because consecutive sides would be congruent. Now I could check all 4 sides, but I'm not going to. So you can see here, after I put in the numbers for JK and KL, I found out those 2 sides are congruent. I'm already presuming that this is a parallelogram, so if I could check the other sides, all 4, I would get the congruent. I'm only going to make y'all do say 2 sides, because we do have a theorem that says if the consecutive sides are congruent, then it's a rhombus. So there you go. So if I just do those consecutive sides there, I've got that as a rhombus. All right, let me do one more example here. Whoops, went too far. Okay, so I had to pause, but let's look at another example here. Let's let this go ahead and just using different points, but using the same letters or whatever. And let's see what happens here. So we're going to go through the same thing. We're going to look at the diagonals first. We're going to do the distance formula for the diagonals and for the sides. And you notice how I will put the numbers in place for the different things. If you're not sure of why I'm doing that, then ask. But notice how I set this up. Distance formula is, again, subtract the x's squared plus subtract the y's squared. Slope is subtract the y's over subtract the x's. So I'm just putting the x's together, the y's together, and then doing that for both. Again, why did I choose JL and KM? Because they're opposite each other. These points should be opposite if they're done correctly in the right order. So those should be diagonals. Anyways, I put those numbers in and I see that I get square root of 260 for both. I also get 14 over 8, which is 7/4, and -8 over 14, which is -4/7. So not only are the diagonals congruent, they're also perpendicular. Because they're congruent, that would suggest a rectangle. Because they're perpendicular, that would suggest a rhombus. And since I'm looking at a rectangle and a rhombus, then that probably means I have a square. Because if I have a rectangle and a rhombus, both properties, then that means it's a square. Okay, so how can I double check that? If I look at the sides here, well, let me go back a little bit here. So let me do the same thing. Let me do, again, the slope. Let me do the sides. Notice here, the two sides next to each other, JK, then KL, I guess you could say like that, they're the same thing. Okay, I could go further and try to check LM and MJ also, but we're already saying this is that. And then you look at the slopes for those sides, and at those sides, they're making a 90-degree angle. So since the sides are congruent and the slopes are perpendicular, that would again suggest a rectangle, a rhombus, which would lead me to a square. And really that's about it, guys. Notice how I try to use the distance formula and the slope formula to help me here. So expect that you need to be able to do that yourself. That's it for today. I'm going to go ahead and stop there. Y'all take care. Thank you so much for your time.